All right, good morning, everybody. So we are going to wrap up our metaprogramming chapter, probably this session, maybe a little piece of next session, depending on how fast we go. This last section of the slide deck on metaprogramming is going to be painless and actually quite useful. Okay, this is something that you are much more likely to encounter. Actually, that's a little metaprogramming trick that we have been pulling in the next, in the previous session, the next slides, in the previous slide, sorry. So annotations are actually something that is, I would say, more and more widespread. Actually, in the Java community, it's used for all sorts of things. At the most basic level, annotation are just metadata. So metadata means data on the data, okay? So it's pretty much information about your program. So it's a way for you, guess what, to annotate your program. A few remarks about this. These annotations have absolutely no effect on the program itself. So you all know what an if statement does, what a for loop does, an iterator does. All of those constructs in the language have an effect at runtime, right? While the annotations do not have an effect directly. They are kind of like a markup language, okay? When people ask you if HTML5 is a programming language, no, HTML5 is not a programming language, it's a markup language. It's different. Try to make a for loop with HTML5, okay? You can do it with external frameworks that interpret the tags in a certain manner, but that's about it, okay? So annotation are kind of in that bag, in that category. They really do not do anything in and by themselves. You mark a piece of code, and then if you want, and this is where metaprogramming comes back in, if you want, you can react to that annotation during runtime. But it's going to be done by another piece of code. Annotations are both compiled, well, actually there's a piece missing here. They are both source time. I never heard anybody use that expression, but I think it's appropriate. When you write your code, annotations are there. When you compile your code, annotation may be taken into consideration by the compiler or any of your build tools, okay? And then at runtime, again, you can take into consideration annotation. And I always prefix my sentence with may or you can or it, because one of the things we're going to learn to do is we are going to learn to write our own annotation. We're going to use to learn the default annotation that are offered to you by the Java language. Then we're going to learn to define our own. Then we're going to learn to mark our own annotation with so-called meta-annotation, annotation that mark over annotation. And when we do so, one of the things that we're going to be able to influence is whether actually our annotation disappears as soon as we start compiling, or remain in the code during compilation, or remain even in the JVM, in the bytecode during runtime, okay? So there's a lot of flexibility actually with what you can do because of that with annotation. So here are a couple of examples of what you can do actually with those annotations. We already mentioned the ability to provide extra information to the compiler. So we already encountered something like that, okay? We encountered the @override notation in one of the previous lectures. Well, that was an annotation, and that was an annotation that was telling the compiler, I'm trying to override a method here. So if you notice that this overridden method doesn't correspond to any method in one of the superclasses, then let me know. Raise an error, okay? Compilation error. So that's one of the things that we're going to learn to do in this session with annotation. Compile time and deployment time processing, we're not going to play too much with that, but the ability to mark your code allows you to communicate, allows the programmer to communicate with the build tools. So any tool that could benefit from knowing exactly what is the intent behind your code, or what part of the code need to be obfuscated, what part needs not to be obfuscated, all of those tools can actually read annotation, okay, in your source and act accordingly. So it's a great way actually to interact with your build environment. And then runtime processing, we are going to actually focus on that one in this course. We are going to introduce annotation in our practice project. And I'm going to show you an example that's going to be like 90%, 99% similar to what you will have to do in the practice project. So we are going to introduce annotation in that basic evolutionary algorithm, and we are going to learn to explore our code at runtime to find those annotation. And hopefully it will show you how meta-programming and annotation together can combine actually to make code that is very, very, very terse, okay? Easy to read still, it's not obfuscated, but it's really, really compact, okay? No repetition whatsoever. So let's talk a little bit about the format of those annotations. So we're going to go over a few examples, okay? Example number 1, that's the basic syntax. At, and for example, entity is the name of the annotation. So notice the uppercase. Annotations are actually sort of interfaces. So that's why they have an uppercase, if that helps you remember it, okay? Every time you use an annotation, think that you are using a class name and interface name. The at symbol, that's what tells the compiler that this is a new thing in Java, which is annotation. Example 2. Well, this one we already saw, okay? At override. So there is a small set of predefined annotation. Most of them actually are meant to talk to the compiler. We're going to see that. So we're going to learn to use those. They are defined in the java.lang annotation package. So that's if you are looking at the documentation, Java 8 documentation online from the Oracle website, go to the annotation package, you'll have the exhaustive list of everything you need to know about annotation, okay? This, and of course, this is based on the Java annotation tutorial trail at oracle.com as well. And then you can make your own annotation just in case you want to mark your code, with things that are useful for other programmer. Like, for example, I didn't know what I was doing when I wrote this method. Annotation can have components inside of them. We call them elements. Okay, so that's added data. So this is where it becomes interesting, because if we could just mark thing, it would be a binary thing, okay? An element in my code is the worst ever method or not. And that's it, Boolean information. But with elements, you can introduce actually more data. So here's an example of an annotation at author that we are going to actually use as a running example. And it has 2 elements inside of it. So it kind of looks like JSON, except that don't make the mistake we all make the first time we use annotation to put a curly brace here. It's not a curly brace, it's a parenthesis. Again, if you need a trick to remember that, you'll see when we define our own annotation, it really looks like an interface, so it looks like the elements inside the annotation are kind of like methods. So who says methods says parentheses, okay? But anyway, you'll make the mistake and then you'll correct yourself. That's not a big deal. But it looks like, otherwise, it looks like JSON format, okay, key value format that you find also in the Java property files. So here the element is name, the value is Benjamin Franklin, the date, here's the date. Interesting thing, by default, you have an element in an annotation that's named value. If you just use one element in your annotation, no matter the data type, okay, you can use by default the value element that is there, okay? And you don't even need to put the name. So we're going to see that in the next examples, okay? Here's another example. For example, we're using here at SuppressWarning, which is another of the Java default, annotation. This is the one that you use when the compiler keeps telling you you're a bad programmer, and you keep telling the compiler, I know what I'm doing. Okay, so that means pretty much shut up. I don't want to hear about this warning. And you can annotate a method, you can annotate a class, you can annotate. We're going to see exactly what are the rules. Okay, but you can annotate anything really almost in your Java program. So whatever is raising the warning, if you don't want to hear about that warning, you just say at SuppressWarning, and the value is a string that represents the warning you want to shut down. So here, for example, we want to shut down an unchecked whatever, that's probably due to a generics misuse or something like that. So please note that when you apply the annotation, you write it right before the construct to which you want it to apply. So for example, in this example here, the top one, at author precedes directly a class definition, so it applies to the whole class. Here at SuppressWarnings precedes a void method, my method definition, so it applies only to that method. Okay, that's how you mark code. There is also a convention that says that the annotation should be on their own line. Nothing really prevents you from writing at SuppressWarnings, value equal unchecked, close the parentheses, and then go immediately void my method, etc. Nothing prevents you from doing that. It's just customary, to put the annotation separate and before the method. Last example is exactly the same thing, except that here we don't even specify the element name. Okay, so because the @SuppressWarnings annotation has only one element, that element exists by default and is name value. Well, if there is only one element and you pass one value, you don't even need to specify value equal. Okay, just makes the syntax a little easier. And then last bit of syntax, if you do not have any value at all, but we already saw that in the previous slide, right? If you do not have any value at all, well, don't even bother with a set of empty parentheses, okay? I do not remember off the top of my head if Java is going to complain if you put a set of empty parentheses. Try it out. Should not complain, actually, should just ignore it, but whatever. All right, another thing you can do with annotation is obviously use multiple annotations. So there's two ways to do that. The first way to do that is to say, I want to mark one piece of code, one unit of code with multiple different annotation. So for example, this one is an annotation with one value, one element, sorry. I decided to name it name because it fits the context of the annotation semantic, which is @04, so it's something about 04s, right? So I have a string element here in @04, but then I have another annotation that I use to just flag which one of my classes, for example, in that application represent ebooks, I guess. So I call that annotation @ebook, and I apply it also to the same code unit, okay? So again, the rule, one per line, all of them prior to the code unit that you're trying to annotate. But there's something else you can do as well. You can use the same annotation multiple times on the same piece of code, okay? Well, it kind of makes sense in that example. Actually, the example is not too bad. If my class is supposed to represent some data related to some ebook, some PDF file, whatever, well, you can have multiple 04 for one document, right? So instead of getting into, well, my @04 annotation needs to have multiple elements, and then how many elements do I need? Well, I don't know, so I need to introduce an array element, or I need to introduce a var_arg element, variable number of argument type of syntax. Well, instead of doing all of that, all I do is I say, well, the annotation @04 corresponds to one 04. And if you so happen to have multiple 04s, just put multiple annotation, okay? So this being said, there is a way to put an array inside an annotation, okay, as element. You can have an element of an annotation that's containing, variable number of element, just like any array in Java. We are going to cover that when we write our own annotation, but this syntax is also a little bit more readable, okay, easier.
So this will represent an array?
Okay, question is this representing an array? Internally, I don't know. Okay, I don't know how the compiler is going to generate, if it's going to revert back to an array, but when you query with metaprogramming that construct, you are going to get multiple annotation. So regardless of how it's really implemented at the lowest level, conceptually, you can consider that you have twice the same annotation here. Does that make sense? I'm kind of like going around the question there, but
if it is not representing an array internally, so will not my name John Smith override the name variable of Jane Doe?
What about those names? Sorry, I missed that.
The name is equal to John Smith.
Yeah.
Will it override the...
No. Good question. Question is, because I have two annotation @04 with two different names, is the name going to be overridden? The answer is no. You keep both annotation.
The name is same. The data name...
They are the same, but the system is going to allow you to see that you have two annotations on this class, and those two annotations happen to be the same type of annotation, okay? Imagine that you define two variables, int x and y, okay? You have two variables, right? They are both int.
But I cannot define two int x and int x.
Yeah, but what you are confusing is you are saying the name is the same than the type. When I say int xy, x comma y, I have the same type name for two different variables, right? Here, when I say @04 name equal Jane Doe and @04 name equal John Smith, the @04, remember what I said at the beginning, annotation are kind of like interfaces. So it's kind of like you were saying, I have two objects. They are both of the same data type, which is annotation at or for. You can have that, right? But they are different because they have different values.
Yeah. So if I want to refer any one of them, so how can I do that then?
Well, we're going to do that in a few slides. So hold on to that thought, okay? We're going to get there. But yes, the question was, well, how do I refer to them? We have an API to do that for us, okay? And actually, that's going to be the crux of what we do in that practice project as well. We're going to mark fields with annotations, so not class or method, but fields. And then we are going to determine at runtime which fields in a class have been marked by our annotation or not. Okay, that's what we're going to play with during the practice project. Okay, and just tidbit of terminology. If you have the same annotation and you allow that annotation to be repeated, it's called a repeating annotation. Fair enough, simple enough. So some of this stuff is really recent, actually. If you look back at Java 7, Java 6, I think Java 5 was generics, if I remember right, the big thing that was introduced. And annotation might be actually even more recent, I'm not sure. But this is fairly recent stuff. So if you are, for example, developing an Android, you know that Android is using actually a different JVM, and it's actually kind of, I don't know if it's still true, but it was true like 3 months ago, something like that. It was frozen at Java 6 or Java 7 version. So what you learn in this course, if you have to program in Java, just make sure that you check first what platforms you are developing on, okay? If you are developing for whatever reason on a Java 6 or Java 7, well, some of this stuff is not going to be available, all right? Okay. So I mentioned sooner that we would go over the rules about what you can apply annotations to. Well, it's almost everything, right? You can apply it to classes, so it's not just classes. Of course, abstract class, okay, are also there. Interfaces, so anything that is similar to the class unique code, pretty much. And then fields, methods, and even over programmed element. But that are declarations. So that's the main type, I would say, of annotation. These are the annotations that apply anytime you declare something, okay? So local variable, even parameters, stuff like that, not a problem. And then you have a second type of annotation. Pun was not intended, but these are called type annotation, okay? Because they can insert themselves wherever you use a data type. So that's even more flexible. So the examples that we have on this slide are interesting. For example, here, I'm saying, I want a new @interned, and then I call a constructor my object. So it allows you to say, I want to mark actually this object creation. I want something special to happen when this object is created. So obviously, because this is happening inside a new statement, it's most likely a runtime annotation here. Okay, we want the creation of the object to be done differently. We could use this kind of annotation to mark, for example, objects as permanent or not. Okay, you all heard of ORPs, object relational mappers. These are like layers of framework, that sit between your programming language and a database, and allow you to say, for example, I'm going to create an object, but hey, I want this object to be persisted into a database automatically. So I don't want to have to worry about writing SQL, writing queries and stuff like that to commit to the database. I completely abstract myself from those problems. The object relational mapper uses actually meta-programming techniques at the implementation level to be able to do this kind of stuff, to read your code, understand what you want, and then commit those objects to the database, save them automatically for you, okay? So you could imagine that, if you don't want to mark an entire class as being all objects of that class are going to be persistent in my database, well, you could have maybe an annotation that allows you to say, when I create a specific object, well, I want that object to be persisted in the database. Okay, so that's just an example of where we could find this kind of stuff. The second example on the slide. Also, yes, question?
So what will be the difference between new the annotation and my object, and annotation new my object?
Okay, so the question is, why do we put @interned before my object instead of before the new keyword?
Yeah.
I would guess because in that example we are trying to annotate my object actually, and not the new operator. Remember in the previous slide, we never said anything about annotating operators of the language, right? We said something about annotating class, method, fields, whatever. And then we talked about annotating data types when they are being used somewhere. So my object is the name of a data type. It's the name of the constructor, of course, but it's a class somewhere, or an abstract class, something like that. So I'm guessing this is why @intern will always go in front of my object as opposed to in front of the keyword new. Okay. That being said, you could have implemented that differently. There are things that are just arbitrary. So I'm never really comfortable about explaining something that's an arbitrary choice when you can all see that it could have been differently. For example, I could say, like in the case of the new operator, I allow buff syntax. It's just a matter that when I see an annotation, if I see the keyword new after that, well, I'm just going to ignore the keyword new and look at the next thing, which is going to be a type name. So it would have been possible to allow more flexibility in the syntax. Whether it's a good or bad thing, I don't know. But so second example on the slide, my string equal @non-null string str. Well, same thing. We are annotating a data type. This time we are annotating the data type string as a class string. And what we're saying here is that we want to assign the reference that is stored inside the variable str to another variable called myString, okay? But we want to check that it's not null. So again, that would be a good candidate for a runtime annotation, okay? We want to add some additional checking, some additional tests, that are going to make sure that str is not null. The beauty of this kind of thing, and this is nothing new. I mean, this is something people have been doing with macros and pre-compilation directives in languages like C and C++ forever. But we could imagine here that you have a global flag when you compile your application that allows you to decide whether you want to run your application in a safe way, meaning every time I marked things like non-null, I want you to actually inject there when you generate the bytecode some extra statement, some if statement that's going to make sure, hey, that value is not null. And if it's null, raise an exception, break, everything, exit the program, I don't care. But do something, don't let it go unnoticed, okay? So you could have an option that turns all of those checks on. But when you run your code, especially if those kind of checks are done in critical section of your code, things that demand performance, you're going to slow down your application, right? So it would be nice to have a flag that allows you to say, I want to run in safe mode, or just forget about all those checks, okay? But when you have a flag like this during compilation time, you don't have to change your code. Everywhere you think you should do a safety check, you put an annotation, right? And then you decide whether you want to generate a version of the code that is going to check actually those things. So you use that during development to make sure your code is not letting a null pointer, slip through. And then when you deliver your tool for production, well, you can remove the safeties, okay? It's probably a very bad advice, I guess, taken out of context. When you deliver something for production, remove all the safeties. So don't quote me on that, okay? But given the context, that's pretty much something slightly different we're talking about. And that's how I'm going to wiggle out of that one. Next example, implement clause. Again, we have a class, let me see, unmodifiable list. Okay, generic syntax, okay, sorry, but we are going to get there probably, this week. Did you have a question? Yeah. Okay, so the question is, going back to the typecast example, are we actually saving the reference here from str to myString? The answer is yes. The part of the question was, are we dealing with the reference or the value? We are dealing with reference, okay? Just easy to remember with Java. With C++, for example, you have the choice, okay? You can have reference pointers or you can have objects in variable. But with Java, it's always references that are stored in variables, right? So here we are assigning the reference that is stored in the variable str to the variable myString. So only operating on references, okay?
And and we are doing a typecasting right in the middle.
Is that the reason we haven't declared a data type over there? So we haven't, it's not like string, my string.
No, in this fragment of code, we don't have, string, my string. We don't have the declaration of the variable. You're right. Just the same way that here we don't have really any context for this statement. Okay, so this slide is a little bit fragmented in the sense that it shows only like really the parts of the code, that are illustrating a specific use of annotations, type annotations. So it's pretty much, hey, this is where you can insert a type annotation. But you're right, if we wanted to make a full example, we would have to declare those variables or even do something with that new @intern myObject, because really, we get a reference back, but we don't assign it to anything. So it's kind of, it's kind of like feeding the garbage collector at that level. It's going to be marked immediately as disposable. Yeah.
Suppose in that first example, I write at the rate annotation, then I write my object, obj is equal to new my object. So will those two be same?
Well, if you declare my object obj and then you say obj equal new @intern my object, yeah, that's the same thing. That's the same thing from the perspective of annotations, right? You just provided an example that makes kind of more sense than just creating, new @intern my object and letting the reference dangle there and be lost immediately. But that would work exactly the same. Nothing changed there. Okay. Keep your focus on really what we are trying to do is annotate code entities, right? So once we decide that we can annotate data types with type annotation, then all those examples are showing you a code fragment where there is a data type somewhere, and they show you can annotate it, and that's it. Okay. So implement clause example, third example of the slide, class unmodifiable list of T. So that's again generic syntax. Most of you have probably seen that in Java because it's really difficult to do any Java even in low-level classes and avoid completely the generic syntax. But we are going to do a full treatment of generic starting next module. Okay. So we have just an unmodifiable list of data types that are of type T, unspecified. Okay. And this class implements an interface that is called list. All right, and we annotated two things. We annotated the data type list, the interface list with @readOnly, and we annotated also inside the generics notation that say it's a list of T representing an arbitrary data type, okay, that you specify at some time when you instantiate the list. Well, we say that type is read-only. So the list is read-only. You cannot delete element from the list, you cannot insert, and then the data type that you store in the list, the object you store in the list, they should not be mutated either. Okay, so that's pretty much what we're doing here. So it's just interesting because this example kind of goes to the next level and shows that yes, if you have like 50 names of data type in one statement, first good luck to read that, but I mean you can annotate just about any of them. Okay, that's not a problem. And then the last thing that is not really showing up here because of this, I'll just work you through it. It's throwing an exception. So we have a void monitor temperature, which is a method, takes no parameter, and we say this method throws an exception named temperature exception. All right, and exceptions are also classes. Okay, I don't know if many of you played with defining your own exception. Anybody did that at some point? You guys really need to try that. It's fun. You're missing a lot there. But anyway, okay, so as soon as you define your own exception, what you do is you subclass a class exception, and that's it. So it's a type name. So anytime you see throw exception this, throw exception that, you can annotate. Okay? So it's just to show you that really, like anywhere you have a data type, you can play like that. So moving on to the next sub part of this lecture on annotation, we're going to have 3 or 4 slides that just go over the predefined annotation that are available in Java. And I don't cover all of them. I tried to cover the ones that we are most likely going to, either that you are going to encounter even if you don't want to use annotation, and the ones that we are going to probably leverage in the practice project. So we already mentioned actually 2 out of the 3. So we are going to go fast over this, okay? They are again defined in java.lang, and that should be actually java.lang.annotation. I will double check, but I'm going to put a warning for the recording and for you guys. Like when it says it's used in the Java package java.lang, double check that. I'm not sure if I didn't make a typo here. So the 3 that we are going to discuss for now: at deprecated, at override, and at suppress warning. Again, notice the uppercase every time, okay? At deprecated. So it's good that you notice the uppercase, because we are going to have an example here where at deprecated appears with a lowercase. So at deprecated, let's start about the semantic, then we'll go back on that bit of syntax, okay? At deprecated means I'm providing you with a class. I'm providing you, therefore, with an API, okay? All my public methods are what you guys, other programmers, can use. Well, watch out. That method, for example, if I'm marking a method, you should not keep using it. So, for example, this is Java 7. I'm one of the core Java developer, and I'm marking a method deprecated. Anybody who is using Java 7 and keeps using my deprecated method is going to get warnings at compilation time, telling them this method is deprecated. So that means stop using it. The next release of Java might not even feature it at all. Okay, so they use that obviously in all frameworks, with Java itself, but any other framework that lives on Java, like if you have an object relational mapper. I mean, I'm sure that these people are going to also use those statements to communicate with their developer community, but you should use it also in your code. Okay, as soon as more than one person uses your code, it's a good way to say I'm going to soon phase out that feature, that class, that method, whatever. Okay, so and now we get back to the syntax. So at deprecated works exactly as we discussed. That's what you can see in the code at the bottom. We prefix a method with the annotation. But if you look at the Java doc that precedes the method, we use also at deprecated, but with a lowercase d. So what's the deal? What is the deal with this annotation here that is inside the Java doc? What can you tell me about it? Mm-hmm. So it's talking to the Java doc, documentation generation tool. So it's saying, I want to generate some documentation here. Yeah. So it's just to make sure that the Java doc says this method is deprecated. Okay. Let me narrow down my question. What is the difference between this annotation here, and I'm pointing at the one with uppercase d, and this annotation here, that is the one with the lowercase d that's embedded in the Java doc? Say that again?
So is the warning from the Java doc the exact string as to why that specific method is?
No. So the remark was, well, maybe it throws the warning from the Java doc. Nope, it doesn't throw a warning, okay? The at deprecated with the uppercase d is the annotation that's going to cause the compiler to say, hey, this method is deprecated, you are using it, I'm warning you. The at deprecated with a lowercase d that is in the Java doc, as you mentioned, is just a way to tell Java doc when you generate the documentation for this method, don't forget to mention it's deprecated. Because by default, annotations do not show up in Java doc, okay? So that's a way to achieve that. So we agree on how it works. My only question is really, what is the difference between those two annotations? It's for different tools, yeah. So the corollary of that is that at deprecated with uppercase d is an annotation. At deprecated with a lowercase d is not an annotation, actually. It follows the same syntax than the annotation, but really it's not an instance of the interface-like structure that represents annotation. It's not part of the code. It's in a comment, okay? So it's more a tag. And I know I'm like going a little bit into the detail here, but this is where bugs come from, this kind of misunderstanding. So when you say at deprecated with a lowercase d, one good way to remember when you need to use uppercase and lowercase is to truly understand what you are writing. Okay? In this case, you are just telling Javadoc, hey, watch out. This method is deprecated. You need to know about that, because Javadoc won't figure it out with the at deprecated annotation. Okay? So two different things. And that's why we didn't use uppercase D here.
So,
You had a question? Yeah.
So if I put a capital D instead of small d, but I'm putting it in a comment, so it doesn't stand a value there also.
If you integrate like a at deprecated uppercase D in a comment, did I catch that right?
Yeah. So
No, it's not doing the job. It's not doing the job because it's not part of your code, right? The compiler doesn't even look at the comments.
yeah, the compiler doesn't look at the comments.
Doesn't.
Yeah.
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 So if you put an annotation in the comment, forget it.
So so why I'm putting at the rate depreciated because a small d, it will not be like.
Well, that goes back to what he was saying. You're talking to different tools. Okay, so the question is, if the comments are ignored by the compiler, why do I put an annotation in the comment? And my answer is like, you are not putting an annotation in the comment. That's exactly what we just said, okay? At deprecated with uppercase D is an annotation.
But it is in comment.
No. At deprecated with an uppercase D, the one at the bottom of the slide, okay? That one is an annotation. It's seen by the compiler. And the whole point here was that this here, this at deprecated with a lowercase d, is not an annotation. It's just Javadoc syntax. You are talking to a different tool. That's actually a very good way to put it. You see what I mean? What's in the comment is for Javadoc. What's outside is for compiler.
What was the purpose of making it a smaller case? You could have made it in a capital case and you put it in the comment. It won't make a difference because it's in a comment. It won't be referred by the compiler. That's
the Javadoc requirement for the syntax, that you use a lowercase d. So the question was, why do we bother making a lowercase d there? That's the Javadoc requirement syntax. And that's also a way to remind you that when you put at deprecated in the Javadoc, it's not an annotation. So it serves that purpose as well. Okay? Make sense? Okay, cool. So that's pretty much it for at deprecated. I mean, I had two pop up here, but I think we covered everything. Let me double check. Yeah, a lot of stuff about lowercase, uppercase. So if you have a quiz question as an exam that says something about uppercase, lowercase in annotation, man, you should remember that, okay? Don't fall for the trap. Watch out for things like that, by the way, especially when I do quizzes, multiple choice, multiple answer quiz. I tend to give a lot of possible answers. Some of them are completely stupid, okay, on purpose, so you should eliminate those very fast. But then what I do is I try to generate distracting statement, okay, things that are almost right, to test whether you are paying attention to details, okay. So just as a heads up, when you take an exam with me and there is a multiple choice, okay, enter paranoia mode. Okay, check the detail. Think that you are debugging something. All right. If it's obvious, it's not a multiple choice. It's just like kindergarten. Okay. So it has to not be obvious. Therefore, it puts you in a situation that you may encounter where you review a piece of code and somebody has written at deprecated, with an uppercase D in the Javadoc, doesn't have any real annotation, and you have to figure this out. That's the point of taking a course and learning stuff. Okay. So. End of side note. At override, next default annotation we are going to talk about. So this one we already covered actually in previous lectures, so I'm going to go fast. It's just you are trying to override a method, right, in a subclass. So you put at override in front, and if you misspell the name of the method, or the signature of the method, also some people call that the header of the method, which means the list of parameters, the data type, the return type. If something doesn't match exactly the method you're trying to override, okay, well then there you go. You are going to get a compiler warning. Okay, so that one is simple. It just shows that, it's annotation are really a way for you to communicate with tools, communicate with the compiler, communicate with actually other programmers, and I just realized what I said. I didn't imply that other programmers were tools, and then communicate with the build tools and stuff like that. So let's move out. At SuppressWarnings. So this one we talked a little bit about it also. So I think I can go relatively fast. The only thing really I want to stress out in this example is you have two types of warnings. Okay, two big categories of warning. One of them is uncheck something, and the other is deprecation, which we covered with the previous annotations. So when you say suppress warning, you can just specify one of them, like here. Okay, at the top of the slide is showing suppress warning deprecation, and then you define a method, use deprecated method, which, as the name implies, is attempting to use a method that has been marked as deprecated. So you don't want to hear about the warning. You know what you're doing, pretty much. Okay, and then you have the syntax here at the bottom of the slide that allows you to suppress multiple categories of warning in one shot. Okay, the only thing that's really interesting in this example is the syntax you can see here. So remember what I said about annotation. Annotation use parentheses when you have elements. It's kind of like a method call. Okay, kinda. So we don't use curly braces. And then here's an example where we use both parentheses and curly braces. The curly brace syntax is from array blocks initializers in Java. You know, when you declare an int square bracket, x equal opening curly brace 1, 2, 3, 4, closing curly brace, is just a way for you to say 1, 2, 3, 4 are the elements of an array of int, store them into my variable as an array. So it's an initialization of variable, and you have a syntax to represent arrays when you do that. That's exactly the syntax we're talking about here. So it's a thing with Java, and that's a thing that people, I guess, are getting tired of. I mean, some people at least. There is a lot of syntax, there's a lot of notation right and left, and sometimes you find the same notations in different contexts. For example, the keyword extends. Okay, we all know it means inheritance. When we're going to cover generics, you're going to see statement where there is an extends and then the name of an interface. Because in the context of generics, the extend keyword means really subtyping, which is a subtle difference, okay? But it allows you to subtype interface instead. Okay, so pretty much in some case you're going to find the same syntax that means different thing. That's not one of them, at least for the curly brace part, okay? The parentheses part, yes, it looks like a method call, and unfortunately, it's not really that, but it's more of a constructor call, actually. But here, the curly brace syntax is actually consistent with the rest of everything you've learned about Java. So let's celebrate at least that.
So,
yep.
@suppress warning deprecation and @deprecated, are they both same, work as same?
Which two statements are the same? Suppress warning deprecation and?
Deprecation, the first annotation that we learned.
No. So the question is, if I understand correctly, okay, correct me if I got that wrong. The question is, it is @suppress warning parentheses double quote deprecation close the quotes close the parentheses the same thing as the @deprecated annotation that we covered before? That's the question? Okay, so the answer is definitively no. The @deprecated annotation allows you to say this method here, right after my tag, my annotation, is to be considered deprecated. This is almost the opposite. This is saying, I know I'm using a method, that is actually deprecated in this method, okay? So there are two methods I'm talking about. The method that you are writing, which is use deprecated method, and then the method that you are calling, which is deprecated method. So in this case, your annotation has the scope of this method, the use deprecated method. Okay? So it's going to affect that method. And it says in that method, if you use anything that has been marked as deprecated, I don't want to hear about it. So it tells the compiler to shut up. Okay, I don't want to hear about any deprecation warning. I know what I'm doing. Okay, I'm using this method until something new and better is available. Just let me be. Okay. All right. So that was kind of a catalog. That's why also I tried to cover no more than 3 or 4. I think this was free annotation, because those kind of catalog can get really boring actually for both you and the person lecturing. So if you want to see an exhaustive list of all available default annotation, go to the java.lang annotation package, okay, and the official documentation. But now what we're going to look at right now is a little bit more interesting because you can make your own. So we're going to learn to define our own annotation and use them in code. So here's an example. the example is again, I mean, those slides are from the Java tutorial trail, right? So this is an example they are using typical, documentation that you want to put in your code for a class. Maybe a little on the long side, but whatever. It's not using Javadoc, okay? For some reason here, the person is just using regular comments to introduce information about their class. Most of that could be done actually with Javadoc, but for the sake of the example, let's say that we have, just regular comments in our code. The idea of this example is we want to move away from this, and we don't want to go the Javadoc route for whatever reason. We want to use actually a custom annotation that we are going to be able to use to tag, a class that we write, and that annotation is going to have a bunch of elements, and the elements correspond to the type of data that is listed here in those comments. Okay, we want an element to store the name of the author, the date, the current revision, etc. So the idea is we want to be able to process that information. Process where? Well, the compiler is probably not going to care about our own, custom annotation, except if we rewrite the compiler. But build tools might. Okay, they might use that to generate actually the Javadoc for us. I don't know. And then runtime can also use that. So we're going to take a look at this. So how do we replace all of this by a custom annotation? Well, here's the syntax. So this is a syntax to define your own new annotation that is called, in this case, class preamble. Okay? Notice the uppercase C, etc., camel case notation. So this is a type name, a data type name. To define an annotation, you use the keyword @interface. Don't look at me. I didn't decide this. There is maybe a good reason for that. The closest I can come to is that annotation are a sort of interface in the way they are defined and what they can do. So yes, maybe that's what generated that name. I don't know. But anyway, @interface class preamble. Okay, you are writing your own annotation. So it's going to sit. If you follow that convention, one class per Java file. Or the rule is one public class or one public interface per Java file. Well, this is going to go into its own Java file. Okay, so treat it like you are defining an interface, a class, whatever. So @interface class preamble, you see the curly brace syntax. So again, curly brace when you define, parentheses when you use. And inside of there, you have the syntax to define the elements. So we mentioned there's always a default element value, right? Well, as soon as you want to insert even one of your named elements, you're going to use that syntax. And it really looks like, again, to continue the analogy with interfaces, it looks like methods that you are defining in an interface that you're writing, okay? So here's a method author that takes no parameter and return a string. Okay, that's just a way to remember the syntax. So that's why also you have the semicolon at the end and all that stuff. So author is not a method, it's really an element in your annotation. So we have an element author of type string, an element date of type string, an element current revision of type int, and a little bit more syntax here. You can assign default value, which means that if somebody uses your annotation and doesn't specify a value for that element, by default, it gets value 1. So same thing for the last modified string, defaults to not applicable. The last modified by string, defaults to not applicable. Okay? And then here's the syntax for doing fancy stuff with array values in annotation elements. So we have an element here called reviewers, supposed to represent the people that have actually, probably from quality assurance, that have reviewed the code actually, and we don't know how many we're going to have. So we discussed about that kind of thing with the @author annotation at the beginning of the lecture, right? So we don't know how many we're going to have. We know that each of them is represented by a string containing their name. So what the hell? We just say, here's an array of string, and that's it. Okay? So that's it. So I'm not claiming that this is all the example of all the syntax of everything you can do with annotation element, but it's like a representative sample at least. Yes, question?
Can we provide the default value for arrays, like array literal?
I would assume so. I've never done it. So the question is, can you provide an array literal? So there's curly brace, initializer, syntax to provide a default value for reviewers for an array. I don't see why it would not be allowed. Let's try it. Okay, if somebody tries it, let everybody know on the forum or something like that. But I don't see why it would not be allowed actually. So, all right. So syntax for new annotation, for new annotation, not that bad. Okay, except that at interface, that's a little weird. How do we use them? Well, the same way that we use any regular annotation. So good news there. Okay, nothing weird. We have an example of code here where we have a class we are defining, generation free list. And before the class, we put our annotation. So at class preamble, name of our annotation, parentheses because we're using, not declaring the annotation. And then the syntax you have seen already a few times now, where we specify the values. So we don't rely, I don't think we rely on any default value here. No. We just specify the values, key equal value, and then comma, key equal value, and then comma, and so on and so forth. And we use that array initialization syntax here, but that's because we pass a value here. So that would be expected, okay? What else? What about Javadoc? So we talked a little bit about Javadoc when we did Deprecated, and we introduced that Javadoc specific syntax, which is at deprecated lowercase d, to say, I want you to mark in the Javadoc that this specific method or whatnot is actually deprecated. Well, we had to do that because by default, none of the annotations appear actually in the Javadoc. That's just the default rule. Okay. In this case, it would be a shame that our annotation did not appear in the Javadoc because our custom annotation really contains a lot of data that is meant to show up in a documentation, right, or for etc. So what we're doing here, we are going back to the file where we defined our class preamble annotation, our custom annotation, okay? And right before the at interface class preamble, which is a syntax to define it, we add an annotation. And this annotation is a default Java annotation called at documented uppercase D. And this tells actually Javadoc, when you generate the Javadoc for that class, make sure to include that blurb, that I had here, that was my class preamble. So it's not going to look pretty, okay? I'll show you an example because we are going to play again with that in a few minutes. It's not going to look pretty, but it's going to be there. So when you look at the Javadoc, you will see, the at preamble annotation and all the fields and their value. So at least the information is there. And that is interesting because silence. It's not interesting, really. No, I'm kidding. This is interesting because it's an annotation in a file where we define an annotation. So that's a meta-annotation. It's an annotation that allows you to tag other annotations.
So,
yes?
We have @interface class preamble here, curly braces. And in the last slide we had @class preamble braces. What is the difference between two of them and which of them is annotated?
Okay, so the curly braces that I used here are exactly the same as the curly braces that are used, let me go back, here.
Yeah.
So it's because we're defining the class preamble annotation, okay? So this slide shows you how to define the class preamble annotation. Then I'm going to move forward 2 slides, okay? I'm still defining the class preamble annotation. I went back to that Java file. I'm just putting an annotation in front of my annotation definition.
Okay, so what was in the last slide?
So now if I go back to the previous slide, this is I use my at class preamble annotation. Difference between defining a class, right? And then when you use a class, you do something like my object O equal new my object parentheses, right? You see the parentheses there? It's because you call the constructor. Now, when you define the class my object, you write my object, open curly brace. So public class, my object, open curly brace. It's because you're writing the code for the class. Same thing here. In this case, I'm using the annotation class preamble to tag one of my classes. In the next slide, I am defining the class preamble annotation. That's why there are curly braces.
So is this a separate class file from where I'm
Hmm?
implementing my class?
Yes, it is a separate class file. What I said when I introduced you the slide where we define class preamble, I said it's kind of like any other data type in Java. You put it into its own Java file.
Okay, so the extension will be .java.
Mhm.
What will be the name?
The name of the annotation.
No, the name of the class of my Java file.
The name of the Java file where you define an annotation is going to be the name of the annotation.
So it will be class preamble.
Yes, it will be class preamble, correct.
So
Right.
isn't it like using an enum?
Yeah, it's like it's like what you do with enum. It's like what you do with interfaces. It's like what you do with classes, abstract classes. Yep. You define actually at a fundamental level, you're defining a data type here. Okay? So it follows all the rules that you have for other data types in Java. All right? Everybody okay with this? All right. So that gives us a great segue into what we are going to probably finish the session with, which is meta-annotation types. So already covered that. These are annotations that apply to other annotation. Okay? So we are going to look at a few examples of them. And we are going to use a predefined meta-annotation. Okay? We're not going to look at actually defining your own meta-annotation, which I realize I never did actually. So that could be funny to try. So let's go through the catalog. There's only like 3 or 4 of them, so hang in there. Repeatable is what allows you to say, this new annotation I'm defining right now. Okay, so let's say we are the people that write the annotation @04. We define it, okay? I want to allow people that use my annotation to mark their class to use several times the same annotation on an entity, okay, on a class, on an interface, whatever. So that's how you mark it. When you define your annotation @04, you mark it @repeatable. So you annotate it with @repeatable, and then that means that you can use it as illustrated in the slide. So not difficult. I'm not showing you yet the code, but we are going to finish with an example where you are going to see exactly where you place those meta annotation, like @repeatable. Okay. Next one, @target. @target allows you, when you are in the middle of defining a new annotation, to annotate it and say, I want this annotation to be applicable to only method, or I want it to apply to anything, or I want it to apply to just fields. Okay. So you see the list here on the screen. I'm not going to go through every line, but that's pretty much what all those options are there for. Okay. So you use @target. You specify as an element value, one of those keywords on the left column, element type dot annotation type underscore type uppercase, and that allows you to say this is a meta annotation. This is an annotation only for method, and so on and so forth. @retention, same thing. You're in the middle of writing your annotation and you want it to be, and now it's interesting because you want it to be kept until X. And you are going to define what X is here. So the first option, retention policy.source, the first value you can pass to this annotation, meta annotation, means that the annotation appears in the source code. Well, yeah, that's fortunate because somebody typed it, so you're not going to go behind them and erase it, I guess. But what it means essentially is, as soon as we start compiling, ditch it. We don't care anymore about it. All right? And then the next one, they're going to be 3 level, obviously. Retention policy.class mean the compiler is going to be able to see your annotation. But as soon as the compiler is done doing its job, it has generated the bytecode, your annotation is never going to show up in the bytecode. It's gone. Okay? So that's the second level. And the third level, retention policy.runtime, okay, guess what? That means that your annotation is in the source. It is kept during the compilation. And even the bytecode that is generated is going to have actually information about that annotation. You are going to be able to process annotation at runtime. This is, by the way, what we are going to use in our example, okay, what we are going to do on the practice project. I think this is the last one we're going to cover. @documented. So @documented, we already used it. We already talked a little about it. So what you see on the right And I should generate my own example because I tried to zoom on that thing and it's not really more readable. But what you see on the right is pretty much the output when you marked an annotation with @documented. You say that annotation needs to show up in the Java doc. Well, this is an example of a Java doc that has been generated for a class. So you see on the top the section on the constructor for that class. So the class name is test annotation. You can see actually method detail for all the methods that are in the class. So this class is a main method. It has a do some test retention and do some test documented method, which we are going to take a look at in the next slide actually. And you can see all the way at the bottom in do test documented Java doc that before actually the signature of the method, we have this tiny print line that says actually, I even have a problem reading it on my screen, @test, sorry about that, @test documented, parentheses, do test document equal hello document. So it reminds you of the name of the annotation that ends up in the Java doc, @test documented, and then with parentheses notation, and it shows you what were the elements that were used and what value were assigned to them with that, element equal value syntax that we have seen before. Okay, so that's what ends up in the Java doc. So if you think about that class preamble annotation that we used as an example before, well, that's where all the class preamble would be showing up. Again, it's not pretty, but the information is still making it to the Java doc.
So
Yep.
my annotation name is test documented.
Yeah.
So annotation names can contain a space in between them.
No, there's probably an underscore there that we cannot see. So the question is, like on the slide, @test documented looks like there is a space between the T and the uppercase D. No, that's not going to happen. There has to be an underscore there. All right. So let's take a look at how we get that done in practice. So that's going to allow us to illustrate also how you apply any of those meta annotation. So again, we are here in a separate file named test_documented.java. So that answers your question about the space. That was really a bad view there on that small print. So we are defining our own interface named test_documented. So public @interface in its own file, and it has one element, and the element name is doTest element. Okay, and it's a string, and that's it. So now what we do is we apply a meta annotation. So @documented applies to what? Applies to the definition of our own annotation. So this is what's telling pretty much that whatever we put in there needs to appear also in the Java doc, which once again is not the default behavior. By default, any annotation are hidden from the Java doc. And then this is our class test annotation where we are going to use that stuff. So we have a main method. Nothing really fancy there. We create an object of the class test annotations, and we immediately call a method do some test retention. And then we create again another object of class test annotations, and we call immediately on that new object the method do some test documented. There's no trick there, there's no trap. The reason for which we don't create a single object, store its reference in a variable, and then call those two methods from the same variable, I don't know. It's just the person who wrote this example wanted to go that route, okay? This is perfectly valid Java, by the way. That just means that once you're done calling the first method on the first object, well, that object technically is available for garbage collection. Okay, nobody has a reference on it, so it's as good as lost. So we do that twice. We call two methods. That class definition contains those two methods on the same slide. So you can see towards the middle here, you have public void do some test retention method that just display on the screen some message saying I'm doing some test about retention. And we use an annotation called @test_retention, and we specify a string as element. So this is another annotation, okay? And then for the last method, we use the annotation, the meta annotation that is the object of this example, really the focus, which is test documented, and we pass to its unique element a string that says hello document. So two basic methods that just do a print, on the screen, and we mark one with an annotation called test retention defined elsewhere, and we mark the other one with the test documented annotation we just defined in the previous slide. And the outcome is what you already saw a few slides ago, kind of a little magnified, still ugly. But this is what's going to appear when you generate the Java doc for that class. So nothing really happening at runtime here, a bunch of println, but these are not relevant. What's relevant is what appears in the Java doc. At inherited, this one is a little bit more tricky, more interesting, more tricky. The base for this meta-annotation is that when you put annotation on a class and then you subclass that class, by default, the subclass doesn't inherit annotations. Annotations are not inherited, okay? So that's the default behavior. It's kind of like, annotation never show up in Javadoc. So it's fine and dandy, and actually it's backward compatible with everything that has been done before the introduction of annotation, so it's a good thing. But that begs the question, what do you do if you want actually your annotation to be inherited? Well, you cannot do anything when you extend the superclass. It's too late. It's when you define the annotation. It's a quality of the annotation itself. When you define your annotation, you have to say, this annotation needs to be something that can be inherited, okay? So you would tag, this is what the middle of the slide shows, okay? This is how you would do, generally speaking. You would tag with @inherited meta-annotation your new annotation that you are defining, for example, my annotation. Then let's say that you have a class employee and you want to apply my annotation to it, so you already know how to do that, okay? You tag employee with @my-annotation right before. And then once you define a subclass of employee, let's say, for example, named secretary, by default, it's not going to have anything except if you did bullet item 1, which is tag inherited @inherited your annotation. In that case, secretary is going to also inherit from my annotation. So if you use the code below, which is, by the way, again, metaprogramming, okay, we create an object of class secretary. Again, we create objects and we throw them away immediately a lot in those slides, okay, because these are just to illustrate what's feasible. So I create an object of class secretary. Don't store its reference anywhere. I call immediately getClass to get the class object corresponding to the class secretary from that object. And then immediately a chain method call, you should be familiar with that. I call getAnnotation, which is metaprogramming, which is pretty much give me an annotation for this class. Which annotation do you want? I want an annotation that is of data type, myAnnotation.class. So it's using the .class syntax to get the class object from a Java data type. Annotations are Java data types of sorts. So I'm just using my annotation name .class. I get the class object, pass that to get annotation. Now it's going to look in the class secretary to find an annotation of type my annotation. And if it finds it, it returns to me an object that allows me to do reflection on the annotation. Okay. In this case, we just want pretty much to use the toString method of that object to get something on the screen that says, hey, yes, we had the annotation, or if we don't get anything, we didn't have the annotation. And in this case, it's going to work. It's going to work because of that @inherited meta-annotation. Otherwise, by default, it will not work. We'll finish with an example that kind of mix in a bunch of different things here. So here are two @interface definitions, so two customized annotation definitions. The first one at the top is called inherited annotation type. The second one, uninherited annotation type. So you can pretty much already see where we're going with that. So we have a bunch of meta annotation on each of those annotation we are writing, okay? The first one, the top one, gets an @inherited, which is okay based on its name, okay, that makes sense. We also specify the target for that annotation, so it can be any data type. We specify the retention, which is runtime. Okay, if we don't specify that, then we cannot actually dig for it at runtime like we did in the previous slide. And then the bottom one, the uninherited annotation type, same thing, except we do not tag it with the meta annotation @inherited. That's the only difference. So we have two annotation, right? One that can be inherited and will be inherited, and the other that won't. So now we need 3 classes. Class A, Class B, Class C. And, imagine employee, secretary, legal secretary. A is a super class. B inherits from A. C inherits from B. So we have a linear, inheritance hierarchy here. Okay. And then we start tagging. So the class A is tagged with @uninherited annotation type, which we know is not going to be inherited as the name implies. Class B is tagged with @inherited annotation type. So that one will be inherited. So you can, again, see where we're going here. And then the last slide, we do a little bit of meta-programming. So sorry for the small print, had to fit on the slide. So we do a bunch of system.out.println. We create objects that we get rid of immediately. So new A, new B, new C, all of that stuff you see. That's kind of like what we have been doing all along. And then every time we create an object of class A, B, or C, we immediately call getClass on it. So we get the class object for that class, and then we use that to do some meta-programming we call getAnnotation. It's really what we did in 2 slides ago, okay? We call getAnnotation, and we say, I'm looking for inherited annotation type, okay? These are the first 3 lines. I do the same thing for an object of class A, B, or C. So the output of those lines is going to be some information that tells me whether I found for that class an annotation of type inherited annotation type or not. Okay? You can see the output here on the second half of the slide. The output is null for the first one, and then @inherited annotation type for the 2 others. So those 3 statements, system.out.println statement, okay, produce those 3 lines here. Do they make sense? Well, in the first line, I'm trying to ask class A, do you have an annotation inherited annotation type? Well, if we go back 1 slide, class A does not have an inherited annotation type. That's defined for class B. Okay? So class A, when I try to check if it has annotation, tells me no. Class B, we just saw that it's actually tagged with that annotation. Sorry, I'm using the wrong terminology here. So when we query it for the annotation, we find it. And class C is not tagged with this annotation, as you can see here, okay? But it inherits from class B, and the annotation is something that can be inherited. Therefore, yes, we confirm that it inherits it. By the way, that kind of CD code is very useful to understand things, okay? When I tell you practice with the lecture example, that's exactly the same kind of code I want you to write, and ask questions about in the forum and come to office hours with, okay? This kind of code has no purpose except making sure that your hypothesis about how things work is indeed what happens. And then the last 3 lines, we do the same thing with ABC, okay? But this time we query whether we have an inherited annotation type in that class or not. So class A has it. I go back 1 slide. Yes. Class A is tagged with this. Perfect. Class B, class C, null. Well, yeah, B and C are not tagged with @uninherited annotation type, and we saw that this is an annotation that is not itself tagged with a meta-annotation @inherited. So it won't go down the inheritance hierarchy. So that explains the output that we get here. Okay, it's up there, but then none of the subclass, direct or indirect, have it. All right. Question?
How deep can an annotation can go in a inheritance chain? Like if I have a class A,
Yeah.
on which inherited annotation type is applied,
Okay.
and then I'm inheriting A with B, I'm inheriting B with C, and then it goes on till here.
Yeah.
So will be inherited annotation, or will it be uninherited annotation?
Okay. So the question is, let's say that I have a class, a superclass, and I keep subclassing it B, C, D, E, F, G, etc. If your superclass has a
My root class?
Yeah, your root class in your example, if it is tagged with an annotation that is marked itself with @inherited, then it will inherit it down the entire inheritance hierarchy. There's no limit. If it's not marked inherited, then it's not going to even go to the direct subclass. Okay, I'm going to stop the recording, and then if you have more questions, you can ask them right away.